Hi everyone, in this video I'm going to show you how to perform atmospheric simulations on the CPAS platform. Before you can move on, you will need your own personal account on this platform first. Click the sign up or sign in button at the top right corner. If you are new to this platform, you can either create a new account with your email address by clicking this sign up button, or you can simply sign in with your Google account. After you have logged in, it then brings you to your personal CPAS platform. First, we need to create a mesh before running simulations, and this page is where you can create your mesh specifications. The mesh specs you have created will be stored in the slots here. To create a new mesh spec from scratch, click the New button in the empty slot here. It then brings you to this interface. You can see a world map in the right panel. This map panel is where you can design and preview your mesh. You can move the map by dragging, zoom in or zoom out by scrolling up or down. You can also change the base map by this button over here. There are several options of base maps you can choose from. In the left panel, there are options to help you create your mesh. First of all, if you want to create refinement regions, there are two options indicated by this pentagon button over here and the circle button next to it. By clicking this pentagon button, it allows you to draw a refinement region in any shape you want. Now you can left-click to add markers on the map. These markers represent the vertices of the polygons you are drawing. Once you have done drawing, click the first marker to close the polygon, and this will be your first refinement region. You can name this region on this text box here. For this case, I will name it GD for Guangdong. You can also change the resolution of this region over the target resolution option here. If I want it to be a 32 km resolution, I can simply input 32 here. There are also options to boost orography and boost coastline. These options allow you to boost the resolution of mountains and the resolution of coastlines in this refinement region here. The second option to draw a refinement region is by clicking this circle button. It allows you to draw a refinement region in the shape of a circle. Now I'm going to draw another refinement region around Hong Kong. I can now click on the map to pinpoint the center of the circle, and you can see the coordinate information are shown here. I can then specify the radius of the circle and click Save to save this refinement region. Now it is represented as Region 2 here. I can also change its name and change its target resolution. If you think that any of these refinement regions does not look good and you want to modify it, you can click the Edit button over here. You can now see the markers that enclose this region. You can simply left-click to remove the existing markers. Or you can add markers by clicking these semi-transparent markers. You can drag these markers to change the shape of the polygon. Once you have done the changes, click Save to save these changes, or click Cancel if you are not satisfied with these changes. To further manipulate the refinement region, there is a button here that allows you to copy the refinement region to your clipboard in JSON format. There is also another button here that allows you to delete the refinement region. For regions outside the refinement regions, resolution is determined by the course's resolution option here, which by default is 128 km. You can change the number by this text box here. With the current mesh settings, the estimated number of cells is around 37,000 to 59,000. This number will change upon any changes to your mesh setting. For example, I'm changing the course's resolution to 64 km. Now you can see the estimated number of cells is changed as well. Next to this number, there is an option to turn on estimation details. By turning on this option, the resolution of the global mesh is now shown in detail. Refinement regions with different resolutions will have transitions in between them. You can now see the estimated transition zone here, and the resolution is around 60 km in this transition zone. The resolution of the transitions is controlled by the maximum resolution gradient option over here. Now, the default setting is 1/12. If I change it to 1/36, you can see the transition zone is widened here. If you want to run a regional model instead of a global model, you can turn on the limited area mesh option over here. You can now draw the boundary for your regional simulation under the limited area domain category here. For example, if I draw a domain around here and close it, it means that simulations will be done in this region only, and there will be no simulation outside this boundary. To turn off this option, simply delete all the limited area domains and switch off this option. After we have completed all the mesh settings, you can give this mesh a name over the mesh name text box here. Now I'm gonna name it as my mesh 2 here. And after this, you can save your mesh by clicking this Save button over here. Now the mesh is saved, and you can go back to the mesh specification page by clicking this My Specs button here. Now you can see the mesh that I just created is saved in this slot here. I can further edit it, clone it, or delete it by clicking these buttons. Click Edit, and it goes back to this interface. Next to the Save button at the bottom here, there is an Export button, which allows you to export the mesh specification in JSON format. Next to it is a Reset button that will clear all your mesh settings and make it go back to the default settings. Now I've confirmed that all the mesh settings are correct, and I want to use this mesh to do simulations. Then I should click the Preview button over here. Now the system is generating a mesh preview here, and it takes time, so we need to wait patiently for this. Now the preview generation is finished. You can see the description of this preview over here. Each polygon of the preview represents around 33 actual cells in the mesh, for my case here. If you want to have a one-to-one preview, which means one polygon represents one actual cell, you can select this preview option here. It then displays the 5 resolution cells in a one-to-one scale. Next, we can proceed to mesh generation. Click the Next button over here. It then jumps to the section of Order Mesh Generation, which allows you to generate the mesh from your specification. You can specify the job name over this text box. I will name the job as my mesh 2 here. The default number of optimization iterations is 50 by default. Here we can have 2 more HTS workload options, and HTS means hierarchical time stepping. The options include time stepping alignment interval, factor for assigning time step. Here I will simply keep the default values for all the options. Click Continue and confirm the order. Now the job is successfully submitted and it will be running on our server. Click the Go to Job List button, which directs to the My Jobs page here. It shows a list of jobs that you have submitted for mesh generation, real simulation, and shallow water test. You can see this job that I've just ordered, and this job is now running on the server by the job status here. You can cancel the running jobs by clicking this Cancel button over here. It takes some time for the mesh to finish running, and when the job is finished, an email will be sent to you to notify you, and the job status will also be changed to completed as shown over here. For completed mesh, you can check the details by clicking this Open Detail button. It shows a summary for this mesh, including the number of cells generated, and here is an HGS table showing the time step for each of the resolution regions, the number of cells, and the computational resource needed for each of these regions. These bar charts also show the quality of your mesh. You may check the explanation of each of them here. Now let's proceed to ordering real simulation for the mesh. Go to the top of the page and press the button Run Real Simulation. This brings you to the section of Order Real Simulation, where you can specify the settings for your simulation. Here you need to specify the initial time of your simulation and the length of simulation. For example, I'm curious about the weather in the next 3 days, so I'm gonna set the initial time as yesterday, 12 UTC, and specify the length of simulation as 84 hours, which corresponds to 3 days and 12 hours. The data source options control which data to generate the initial condition. Currently, you can choose among GFS, FNL, or YARI5. You can also control which CPAS version to use for your simulation. By default, it uses the most recent stable update. CPAS also supports the use of 4-dimensional data assimilation. You can turn on this option if you want to use this feature. There are several FDD options that can be tuned. Here you can choose which data source to use for the nudging data. Here you can change the update frequency, and here you can choose which FDD scheme to use. Here you can choose which variable to nudge or not to nudge by turning on or off these options. For the variables that you have chosen to nudge, you can fine-tune the nudging coefficient, choose whether to nudge in PBL, which means planetary boundary layer, and specify the lowest layer to nudge this variable. The modal physics can also be tuned under the model options. Currently, CPAS allows you to change which physics width to use. You can also change which confession scheme and PBL scheme to use. Last but not least, you need to specify the details of the simulation outputs. First of all, you can change the name of the output file over this text box here, which by default is diag. You can also change the output interval here. You can also choose the output variables in your output file in the left box here. These are the selected variables that will appear in the output file by default. You can add more variables by searching over the right box here. For example, if I want to also have potential temperature in my simulation output, I can search for potential temperature and select the variable. You can also deselect it if you don't need this variable. Finally, after adjusting all the simulation settings, the computational cost and I/O cost will be estimated and shown here. Click the Continue button and confirm the order. Now the real simulation job is submitted and run on our server. Similar to mesh generation, you can check the job status in the My Jobs page. When your simulation is finished, an email will be sent to you and the job status will be changed to completed as shown here. If any of your jobs is failed, the job status will be changed to failed as well. An email will also be sent to you to notify you about this and tell you the reason why the job is failed. To order shallow water test, the procedures are similar to ordering real simulation. Go to Mesh Generation, click the button Order Real Simulation Job for the mesh. Here, instead of ordering real simulation, switch to Order Shadow Water Test by clicking this button. Here you can change the job name, switch the test case, and change the length of test. Click Continue and confirm the order. The shadow water test is now submitted and is running on our server. The job status is also shown in the job list here. To visualize the results of your completed real simulation or shadow water test, click the Visualization button at the top bar here. It brings you to your own Jupyter Notebook server. Click Start My Server. Here you can see a Jupyter Notebook file called cpasfirst.ipynb. Open this file. It contains the Python codes that help you to visualize your mesh, your real simulation results, and the results of your shadow water test. There are also some other code sections that help you visualize and evaluate your simulation results. It should also be noted that you have a limited amount of computational resources for your simulation jobs and the Jupyter Notebook server. Go back to the CPAS page and go to My Subscription here. Here you can see your current plan and the effective period of your plan. And below shows the computational resources available for mesh generation, real simulation, visualization, and utility for your plan. For example, I have a mesh with this kind of setting, and the estimated number of cells is around 64,000 to 1 million. Because I have a cell limit of 50,000 of mesh generation, so it passes the cell limit. Let's go check what happens to the mesh preview. As you can see, the preview stops and it shows an error message about the number of cells reaching the limit. If you want to increase the amount of resources you have for your simulations, go to the My Subscription here. Then go to the bottom of the page and click Change Plan. Here is a table showing the details of what each plan can offer. Here, select your desired plan option and your desired plan period. Then click Buy Now at the bottom of the page. It then jumps to the page where it requires your payment. Now I have paid for a 1-month standard plan. You can see my current plan is shown as standard. The effective period is a month. Here the cell limit for mesh generation is also increased to 1 million. So now I'm able to use a better mesh for my simulations. Finally, if you want to get more details, you may go back to the main page of CPAS by clicking the icon at the top left corner. Go to Support and visit the user guide. Here you may find more detailed information for each of these sessions. I hope you enjoy your experience with the CPAS platform. Bye-bye.